Hey math campers, I'm Miss Ticey. You can think about like tie and then you see something. Welcome to Math Camp. Today we are going to go over percents, solving equations, one step and two step, and then get into triangles with like Pythagorean theorem. So the first thing we're going to do is learn about percents so that if you get a score on a test, you can easily find the percent. I'm going to go over that first just because I feel the start of the school year we sometimes forget how to find the grade you got on an assignment. So the example that I'm going to go over first is 25 over 30. So let's say you got a 25 out of 30. 25 is the number you got right and 30 is out of the total possible score. Percents always work with, or always is a ratio with the denominator over 100. So if we have 25 over 30, you could easily find the percent by taking your top number, your numerator, and dividing it by your bottom number, your denominator. So we're going to take 25 and we're going to divide it by 30. And you could easily do this in your calculator, but for the sake of teaching you something, I'm going to do it the long way. And also you want to make sure that what you're typing in your calculator is correct and that the answer that you're given by your calculator is reasonable and makes sense. So 30 cannot go into 2, so I'm going to place a 0. 30 cannot go into the 25, so another 0. Extend this out. I need to add a decimal, so now I have 250. 30 can go in 258 times. So we have 3 times 8 is 24, and I'm just going to add a 0. So 250, subtract by 240. We have 10 left over, add a 0, add another 0. 30 can go in 100 3 times. And that's 90, and then that's going to be another 10, add another 0. This 3 is going to be repeated. So now we have 0.83 repeated, or 83 hundredths. To make that number into a percent, we are going to move the decimal place over 2 times. Oh, sorry. You can't see that. I'll erase this part. We're going to move it over 2 spots to the right, that's better, to give you 83%. And normally 83% is that B range. Okay, so I talked about before how a percent always has a denominator over 100. Sometimes, like on a test, you will have, it's going to be easy. I know I have a test out of 100, so it may be, let's say 83 out of 100. Well, this one's easy. That just translates to 83%. You could go through the long way of taking your numerator, dividing it by your denominator. So again, we have 83, and that's going to be your dividend inside, and then your divisor is 100, and then again, you're looking for that quotient. So if you did it the long way, your calculator, it would still be 0.83, which we move it over twice, and you get the 83%. So again, it kind of works out. When you have 100 on the bottom, it's just going to be that top number, your numerator, and with a percent sign, so 83%. Back to our original problem, when we had 25 out of 30, this is called a ratio, so percent is a ratio, and you have your top number over your bottom number, kind of like your part and then your whole. Ratios can be left like this. It could also be 25, and you could have 2 and over 30, or also 25 with a colon and 30. Those are just different ways to express a ratio. All right, we're going to go back to harder problems, just like 25 over 30. Let's say that you had a score or a test or quiz, and it was 36 out of 50. Now, like what we did with the 25 out of 30, you could divide the 36 by the 50. Or if we know, like I've said before, a percent has a denominator of 100 always, we can think, or we can try to find out what times 50 would give you 100. 50 times 1, 50. 50 times 2 would give you 100. So if I multiplied 50 times 2, now I'm going to do the same thing with the numerator of 36. So 36 times 2, and that's going to be 72. So 72 over 100 translates to 72%. Hopefully you guys can see that. Okay, so the next one that I'm going to do is going to be a little bit harder than this one. This one worked nicely. Let's say we have 30, what's the one I want to do? Let's do 34, I think that'll work, over 40. So instead, we could take our 34 and divide it by 40, then move your decimal place over 2 spots to the right, or let's try to get the denominator of 100. Same thing, 40 times 1 is 40, too small. 40 times 2 is 80, again too small. 40 times 3 is 120, so nothing will easily go into or evenly go into 100 when multiplied by 40. So instead, we're going to set up a percent proportion. The way percent proportion works is we have 34 over 100 equals percent over, or 34 over 40 equals percent over 100. This is your A over B, which is really your part, over your whole, and then you have your percent over 100. We're looking for that what percent. So the way a percent proportion, or the way I like to teach it, is your is, so I'm going to erase your A and your B, is over of, actually let's just go down here, is over of equals what percent, or you can just have your percent here, or even just a variable x, because that's what we're looking for, over 100. We have 34, we have 40, I'm going to place in an x. With proportions, you want to cross multiply. So 34 times 100 and 40 times x. And this actually leads right into solving equations. So we have 34 times 100. 34 times 100 equals, and then we want 40 times x. It does not matter if you have your 40 and x over here or 34 times 100 here. They'll work out the same way. So 34 times 100, the easy thing to do, we just add 2 zeros to the 34. And now it's 3,400 or 3,400 equals 40x. We're trying to solve the equation to find what x is. And one thing when you solve equations, you want the variable by itself. So right now I have 40x. We're currently multiplying, so now I'm going to divide by 30. I say cancel out, but it's the same thing as divide out here. What you do to one side of the equation, you have to do to the other. So now I'm going to divide by 40. I'm going to erase this part down here. To simplify this problem, I'm just going to cancel those out. Now I have 340 over 40 equals x. Now I need to divide here. So 340, divide by 4. 4 cannot go into 3. 4 can go into 34 8 times, which is 32. We have 2 left over, bring down our 0. 4 can go into 20 5 times. So now we have 85 equals x. Now what we were talking about before this, I'll erase this, we had 34 over 40 equals a percent over 100. And that means 85 should go there, so it's going to be 85 over 100, and that is just 85%. So you have a bunch of ways of finding percent using either decimals or fractions. So if you have a decimal, let's just give you 0.67. You would move it over 2 spots to the right to give you 67%. If you have a fraction, you could choose, let's say, 2 over 5. You could divide your 2 by your 5. 5 cannot go into 2, 0. Put a decimal point, another 0. You go in 4. So now we have 0.4. Just like we did before, I'm going to move it over 2 spots. I'm going to add a 0. This becomes 40%. Or you take your fraction, 2 over 5, and try to find a denominator of 100, either with your percent proportion or with finding, just looking at this, 5 times what will give you 100? Well, the easy way, 5 times 20 will give you 100. So I got to multiply by 20, and it's again 40 over 100, which is the same thing that we did before. So multiple ways to find the percent. So if the teacher doesn't give you an A on there or the percentage on there, you can easily take the fraction and find what grade you got. Now we're going to go to the next topic, which is solving one-step and then two-step equations. Hold on for a second. Before we get to actually solving them, we need to make sure we know how to simplify an expression, because sometimes when we're solving equations, we have to first combine like terms or use the distributive property. So the one that says simplifying expressions. Okay, so first we're going to go over vocab for simplifying an expression. So we have, for the section vocab, 6x plus 5x plus 8. See it on there? No, up one. There you go. Okay, so we have terms. Terms are the part of expression that are added together. Anything in front of the term is going to stick with it. So here we have 6. Okay, that's just 6x. That's just 6x. We have a plus 5, and that just translates to a positive 5. If you were to have a subtraction sign, that would go with the 5x, so that makes it a negative 5x. And then you have an 8. So when we label terms, it's just going to be everything that's added together. Like I said before, if this was a subtracting 5, you could also say you're adding the opposite, so that's why it becomes a negative 5x. Then we have coefficients. Coefficients are going to be the number part that's attached to a variable. So here, and you can see on the whiteboard, coefficients, it's going to be the number part. So anything that you have a variable, you just want to label the first number, the number that's in front of that variable. So the coefficients of this expression are going to be 5, 6, and 5. Then we have a constant term. Constant term just means it stays the same, so we haven't done anything special to it, and that would be 8. I say it's constant, we haven't done anything special with it, because normally throughout all, I guess, your elementary math, you've just seen numbers, nothing with variables. So now we have x. And then we have like terms. And this is how we actually get to simplify an expression. We want to combine any like terms. So whether you have multiple constants or you have multiple coefficients with the same variable. Here in the original one, we had 6x and 5x, and we're adding them. So that's going to turn into 11x. And then that's it. So we have now 11x plus 8. This expression of 6x plus 5x plus 8 turns into 11x plus 8. All right. The next thing that we're going to go to is solving more like this by making sure that you know what a term, a coefficient, like terms, and constants are. You need to have a real grasp of this before you get to solving equations. So I have a chart. It says identifying the following for each expression. It's going to be, the first one we're going to look at is 3x minus 4 minus 6x plus 2. And then I have different charts for you to fill in your terms, your like expressions, your coefficients, and your constants. So the first thing we're going to identify are your terms. Remember that your terms are everything that's being added together. So here we have 3x. It's important to look at what goes in front of that sign. There is nothing in front of here. If there was, there'd be probably a negative sign. If there's nothing, it just means positive. So that is just going to be, or if there's nothing, it's just positive, so it's just 3x. Here we have a negative 4. Or you could say subtracting 4, but when you say identify a term, it's going to be a negative 4. I think it's better if I put it. And then you have subtracting 6x. Again, that negative sign stays with the, or subtracting sign stays with the term, so it's going to be a negative 6x here. And then you have plus 2, and that just translates to a positive 2. Now we're going to go ahead and identify your like terms. Your like terms have either the same variable parts or they're just constants. So if I look at the terms, I have 3x, that doesn't work, and then a negative 6x. So 3x and negative 6x. Another like term, we've already done this one, it's going to be a negative 4 and your 2. So we have negative 4 and 2. Now next thing, let's just identify coefficients, just so you're, I guess, aware of and get used to identifying coefficients, so you can add them together at the end. So coefficients. It's a number part of your variable. So here's my variable. I'm going to identify that as 3. And here's another variable, and that's just going to be the -6. And the last thing is your constants, and that's just any number that's just by itself. So the numbers that are by itself with no variable attached are going to be a -4 and a 2. Eventually, in the later slides, we're going to get to actually combining them like we did the first example, but I just want to get used to practicing this. So let's go on with the example number 2. Whoops, just broke your thing, sorry. All right, so the next example is -13x, -5, and -4x. So again, let's identify our terms. Our terms are everything that's being added together. So the first example, I didn't change anything with my original expression, but this time I am. I want to change all my subtraction signs to adding the opposite, because that's one of the rules when you are simplifying expressions, or subtracting integers. You add the opposite. So here we have -13x, and I'm going to add, and then the opposite of a +5 would be a -5. I'm going to just change that so you can see it. -13x -5 -4x was the original problem. I added the opposite. And then we have subtracting 4x. So instead, I'm going to add, and the opposite of a 4x is a negative. So now it becomes the original problem or expression was -13 -5 -4x. Same thing, I just added the opposite. It's going to be -13x plus a -5 plus a -4. All right, so let's identify our terms, everything that's being added together. Here we just have a -13x. Another term, we have plus a -5. I just want the -5, what we're adding together. We're adding a -5. And then we are adding a -4, so a -4x. So now -4x. Now we're going to identify your like terms, if there are any. I have a -13x. There's no variable x, so that's fine. And I have a -4x. So those are going to be my like terms, -13x and -4x. Eventually, in the later ones, we're going to end up combining those like terms like we did with that first example. Coefficients, anything in front of the variable, any number. So I'm going to find my variables. Here's one of them, the x, and here's the other. I want the number that's in front of it. I don't want to keep that variable attached to it. So now I have -13, and the other one would be a -4. Constants is the number, or I guess a term that has no variable with it. So this one has a variable, can't do it. This one doesn't, so that's one of them. This one doesn't, so that's the only one. Should I have been going up? Oh. Okay, so here we are. We have one more example before we actually get to simplifying the expression. Erase this one. And I don't, can they see all of us?
No, but just start up a little bit now.
Okay. Move it just a little, sorry. All right, the last one that we have before we actually get to it, simplifying, is going to be -7y plus 8 minus 6y, and then minus 13. So we want to identify the terms, identify like terms, identify coefficients. Oops, spelled it wrong. And then identify the constant terms. All right, for terms, again, everything that's being added together. So we have a -7y plus 8 minus 6y. We're going to do that. So instead, we're going to add the opposite. So add the opposite of a 6y is going to be a -6y. Then subtracting 13. So we're going to add the opposite of 13 is a -13. You don't have to always add the opposite. Instead, you just need to know that whatever's in front of the sign stays with it. Again, we have a -13, like I circled up here, a -6y here. So our terms now, everything that's being added together, a -7y, an 8, -6y, and a -13. Now I'm going to go through and identify my like terms. Either they have the same variable parts or they have no variable at all. Negative 7y I'm going to start with. And then we have another variable of y, so and negative 6y. My other like terms just are constants. Here's an 8, and then we have a 13 at the end. Now we're going to identify the coefficients. That's the number part of a variable. So I'm going to look for the variables. Here's a variable, negative 7, and I don't want the variable with this right now. And then we have a negative 6. Constants are any terms that have no variables at all. So we have an 8, and then we have a negative 13. Now that you know at each part of an expression, now we're going to actually get to simplifying the expression. So the first example that I have is going to be 4f minus 7, parentheses, f plus 3. So I'll write it down, 4f minus 7, parentheses, f plus 3. All right, to start off, I'm going to do it where I add the opposite. So I'm going to have the original problem. I'm going to write again 4f minus 7, parentheses, f plus 3. And again, everything that stays in front of it, the sign that's in front of it stays with that number. But some people forget about that, so I'm going to add here. I'm adding the opposite of a 7 is going to be a negative 7. The reason I want to make sure you do this correctly is because we need to distribute this negative 7 to the f and to the 3. So we have 4f plus a negative 7 times an f. If I put it off to the side, negative 7 times f. Whenever you have that, you're just going to put them together. So it's going to be negative 7f. So negative 7f. And then you have a negative 7 times 3, which becomes a negative, so plus a negative 21. You don't have to have a plus a negative if you want to, kind of like our original problem had. We have 4f minus, ooh, that should be a 7f, sorry. Minus 7f. And then a minus 21. From what we did before, now we're going to combine any like terms. And we know we've done really 4 examples of combining like terms. So here are like terms because they have the same variable parts. We need to add together a 4f and a negative 7f. The rule with adding integers is if we're subtracting, we're going to take the sign of the larger absolute value. So here we have it because they're different signs. We have a 7 and a 4. Because it's negative, we're going to take the sign of the larger one. So our answer is going to be a negative. Now we're going to subtract. 7 minus 4 is 3, and then we keep that f with it, minus 21. So our final answer for this, oh, I got to put it up higher. For this original problem, we have negative 3f minus 21, or what we could say is negative 3f plus a negative 21. Both of those mean the same thing. And on a test or standardized, or if it's for your teacher, they're going to have one or the other. They're never going to have both because they mean the same thing. Okay, let's do the one that's below that on your whiteboard. We have 5 parentheses d plus 6, close your parentheses, plus 8d plus 1. So 5 parentheses d plus 6 plus 8d plus 1. I see parentheses here, so that's the first step that you're going to want to take to simplify this. I'm distributing my 5 to my d and 5 to the 6, and that 6 is positive because we have a plus sign in front of it. So 5 times d, like I said before, whenever you multiply a number with a variable, just stick them together. So we have 5d, and then we have a plus sign, and then 5 times 6, and that's going to be a 30 here. We have now plus 8d, and then plus 1. From here, now we have to combine like terms. There's no other parentheses, so we're fine. Combining like terms, I'm going to start off with whatever comes first in my expression. You don't have to. You can just go with whatever you like. So I'm starting here. I'm going to look for any variables that are d that I can add together. If there's nothing, then there's nothing. I'm just going to place it down. D, nope. And then here's another one. And then we're adding. So we have 5d plus 8d, and that becomes 13d. I don't think you guys can see that. And then we have 30 is the next one that I'm going to look at. And then we have 1. And those are your constants, so 30 plus 1 is just going to be 31. So our original problem of 5 parentheses d plus 6 parentheses plus 8d plus 1 is the same thing as 13d plus 31. All right, let's see the next one. I think I have one more, and then I'm going to have you, oh no, we're not doing quizzes, right? Then we're going to go solve the equations. All right, the next one is 4f. Oh no, I already did that one.
If you want them to do something, they can do that.
Later, or should I take now?
Yeah,
Now?
I want to.
Okay, there is a quiz that I would like you to take. It's a simplifying expressions quiz in the assessment of bquiz. So if you look for assessments, it should say expression.
Resources.
Oh, in the resources?
Tell them to go to resources first.
Okay, so you want to go to resources, and then you're going to look for assessments, and then you're going to see one for simplifying expression.
Go to their assignments.
Oh, go to your assignments.
And it'll be the only thing in their assignment page, right? You haven't assigned anything else?
No, I just have it on the resource page.
Okay.
For them to
No,
use.
yeah, tell them to go to resource, go to assignments. It's your first assignment.
Okay, go to resources, then go to assignments. It's going to be the first assignment that you see.
And how long do they need?
About, let's say, take 5 to 10 minutes for
Okay.
doing that.
All right, and we'll come back then.
All right, I'll see you later. I forgot.